In today's video, we will be looking at cubic functions as well as quadratic functions. Now remember that a quadratic function is the first derivative of a cubic function. In fact, you can draw a quadratic function from a cubic function. Let's say we had x cubed being a cubic function. Now, the fun fact is the x values of the turning point of a cubic will be the x values of the x-intercept of a quadratic. Okay, so if you look at the turning points of a cubic, in order for you to draw a quadratic from a cubic, the first thing you do is you need to remember that if you're given a cubic and it's increasing, then the derivative of the cubic will be a quadratic that has a smiley face. If you're given a cubic that's decreasing, then the derivative of the cubic will be a quadratic and he'll have a frowny face. Okay? The second thing you need to remember is the x value of the turning point of a cubic will be the x values of the x-intercept of a quadratic. The only thing you know is, and the only thing you do is, you need to just draw dotted lines to the x-intercepts or to the x-axis from the turning points, and then you draw your parabola. The point of inflection of your cubic, the x value of it will be the x value of your turning point of your quadratic. So the x value of your point of inflection of a cubic will be the x value of your parabola of your there will be the x value of the turning point of your parabola. All right, the x value of the point of inflection of a cubic will be the x value of the turning points of a quadratic. Now let's look at a few examples. Here, our point of inflection, let's say it's at 0. The first turning point will be, let's say, -4, and this turning point will be, let's say, 5. Now remember the rules. If you have an increasing cubic, then the derivative of the cubic will be a smiley face. And then if you have a decreasing cubic, the derivative of the cubic will be a frowny face. That's the first thing you need to remember. The second thing you need to remember is if you have a cubic and you have a quadratic, well, you need to remember that the x values of the turning point of the cubic will be the x values of the x-intercept for your quadratic. Let's use this information to draw our parabola. We have an increasing cubic, meaning our parabola will be a smiley face. We have a point of inflection, meaning the turning point of our parabola will also be on that line, where the x value of the point of inflection lies. Our parabola now will look more or less like this. Sharing the x values of the turning points of the cubic and also sharing the x values of the point of inflection of the cubic. Let's look at another question. We are given a. Now we need to remember that if you have an increasing cubic, the derivative of the cubic will be a smiley face. The second thing you need to remember is the x values of your cubic of the turning point of your cubic will be the x values of the x-intercept of your quadratic. If you have this information, you're good at drawing the parabola. Now all I will do is I'll put my dots on the x values of the turning point of the cubic. I will look at my point of inflection and just draw a line, a dotted line on that line. And then once I'm done is we just connect the dots. Let's look at another question. Here we also apply the same information. If you have a decreasing function, that means that the derivative of your decreasing function will be a frowny face. Secondly, we need to remember that the x values of your cubic function, the x values of the turning point of a cubic function will be the x value of the x-intercept of your quadratic function. All we need to do is put our dots under the x values of the turning point, put a dot or draw a dotted line, and then put a dot on the x value of that dotted line from the point of inflection. We know that our parabola will be a frowny face because our cubic was decreasing. All we do is we connect the dots, and this would be our h prime of x. Let's look at another question. Here we are given the derivative as stated here. Can we find the cubic from the derivative? Of course we can. We remember that if you are given a frowny face quadratic, it simply means that the cubic was decreasing. If you are given a smiley face quadratic, it simply means that the cubic was increasing. And the second part of the information is the x values of the turning point of our cubic will be equal to the x values of the x-intercept of our quadratic. Here we are given a frowny face. It means our cubic will be decreasing. Our x-intercept are here. That means that if we draw a dotted line, the x values of our turning points will be on these vertical dotted lines. And since we have a frowny face, it means we will have a cubic decreasing function, meaning our minimum, local minimum, will be somewhere there, and our local maximum will be somewhere here. We have the turning point of our quadratic. That means that our point of inflection will be somewhere along that line that our turning point lies on. All we do is we connect our dots and that's how our original h of x will look like. Let's do the last question. Here we are given a smiley face. We need to remember that an increasing cubic will give us a smiley face quadratic. We also need to remember that the x values of the turning point of a cubic will give us the x values of the x-intercepts of our quadratic. So we have an increasing cubic, that's what we know. But how do you draw a cubic from a quadratic? Remember, just draw dotted lines on the x-intercepts of our quadratic, and somewhere along those dotted lines you'll have your turning points. And also draw a dotted line on the turning point of our quadratic, because somewhere down the line you will have, or somewhere on the line you'll have the point of inflection of our cubic. We know that this guy is increasing, meaning our local maximum will be there along that line, and our local minimum will be along this line. Our point of inflection will be along this line. All you do is you connect the dots, and our cubic will look like that. Thanks for watching. See you in the next video.